On this F150, P0330 may point to a knock sensor signal problem. In plain terms, the PCM is seeing the knock sensor voltage drop below or move outside the calibrated range for that fault type. The truck may need to be driven for several minutes before the fault sets. The driver may only see a check engine light, but depending on the real fault, there can also be spark knock, an audible engine knock, or other drivability complaints. Keep your mind open to sensor installation, wiring and connector problems, the sensor itself, fuel or ignition issues, real engine noise, cooling or oil-related concerns, air charge restriction, and the PCM. But for P0330, start by proving the circuit before condemning parts. Start with the basic system checks. Turn the ignition on and see what codes are actually present. If other codes are present, check what they mean first, especially if they change the direction of the diagnosis. Also make sure the knock sensor is installed correctly before you go deeper. If P0330 is the code you are working, stay on the knock sensor circuit path and move into the electrical checks. If the expected knock sensor code is not present, do not force this test path. Use the symptom direction instead. With the ignition off, disconnect the knock sensor connector used for this test and disconnect the PCM connector. For the 2.7 EcoBoost P0330 path, check the KS21 circuits between C1047 pin 3 and C1233E pin 10, then between C1047 pin 6 and C1233E pin 31. You are looking for each resistance to be less than 5 ohms. If both are less than 5 ohms, the circuit is not open and you continue. If either one is not less than 5 ohms, repair the open circuit, clear the PCM DTCs, and repeat the self-test. Next, check the same knock sensor circuit for a short to ground. On this 2.7 LKS21 path, the check is made at C1047 pin 3 and C1047 pin 6. The resistance needs to be greater than 10K ohms. If it is greater than 10K ohms, keep going. If it is not greater than 10K ohms, repair the short circuit, clear the PCM DTCs, and repeat the self-test. Now turn the ignition on and check the KS21 circuit for voltage where it should not be present. Measure at C1047 pin 3 and C1047 pin 6. If any voltage is present, repair the short circuit, clear the PCM DTCs, and repeat the self-test. If no voltage is present, move on to the intermittent check. With the ignition off, watch resistance while you work the harness. Wiggle, shake, and bend small sections of the wiring from the sensor toward the PCM. For KS21, monitor between C1047 pin 3 and C1233E pin 10, and between C1047 pin 6 and C1233E pin 31. The resistance should stay less than 5 ohms while the harness is being moved. If it stays under that limit, continue. If it does not, repair the open circuit, clear the PCM DTCs, and repeat the self-test. Reconnect the PCM, turn the ignition on, and check the bias voltage on the KS21 circuit at C1047 pin 3 and C1047 pin 6. The voltages should be between 2.7 V. If they are in that range, install a new knock sensor, clear the PCM DTCs, and repeat the self-test. If the voltages are not between 2.7 V, continue to the PCM operation check. The shared diagnostic path also has a knock count branch for cases where the scan results point that way. Before using it, deal with any audible engine knock as a mechanical noise concern. Then start the engine. Watch the individual cylinder knock count PIDs in the PCM and decide whether most of the counts are concentrated on one cylinder. A single cylinder pattern points you toward ignition coil and fuel injection components for that suspect cylinder. If the counts are spread across multiple cylinders instead, continue into the knock rate check. For the knock rate check, listen for any audible knock during the drive because it may not show up at idle. Drain and clean the fuel system. refill it with the correct grade fuel, start the engine, record the captured fault conditions, clear the PCM DTCs, and reset the keep alive memory. Bring the engine up to normal operating temperature, then monitor the cylinder knock count PIDs during the road test. Drive with mid to high throttle to create high continuous load without causing a downshift for 5 to 10 miles. If knock counts increase, move to the next decision. If they do not increase, the system is operating correctly at this time. After that road test, turn the ignition off and decide whether an audible knock was present while driving. If it was audible, check for base engine concerns, repair as necessary, clear the PCM DTCs, and repeat the self-test. If there was no audible knock, think about non-mechanical sources that can fool the knock signal. Harness routing, alterations, incorrect shielding, fuel injector noise, or electrical interference from systems like ignition, generator noise, or radio frequency interference. Correct any concerns you find. If no other concern is present, install a new KS, clear the PCM DTCs, and repeat the self-test. For the PCM operation check, turn the ignition off as needed, disconnect all PCM connectors, and inspect for pushed-out pins and corrosion. Reconnect every PCM connector and make sure each one seats correctly. Then verify whether the concern is still present. If the concern is still present, install a new powertrain control module. If the concern is gone, the system is operating correctly at this time, and the fault may have been caused by a loose or corroded connector. Keep verification separate from testing. After any circuit repair, sensor replacement, connector correction, PCM replacement, or repair made from the knock count branch, clear the PCM DTCs and repeat the self-test. The goal is simple. Prove the code stays gone under the same diagnostic conditions instead of just clearing it and shipping the truck. The clean way to diagnose P0330 is to prove the knock sensor circuit first. Open, short to ground, short to voltage, intermittent wiring, then bias voltage. If the scan results send you into the knock count side, separate real engine knock from signal noise before making the call. For more diagnostic training, visit stepdiagnostics.com.